In this video, we're going to learn how to write exponential equations when given 2 points on that exponential equation. So let's jump right in here and start solving our first example. So here it says, write an exponential function in the form y equals a times b to the power of x. So for all of these, we're going to be writing our exponential function into the form y equals a times b to the power of x, which means we're only going to need to find an a value and a b value. So we don't have to worry about finding, the other b, h, and k. We're just going to find our multiplier each time, which is our b value, and the a value each time, which is the value out in front that vertically stretches and shrinks it. Now, for this particular exponential function, we're going to be looking at 2 points. We have the points 1, 6 and the point 3, 54. So those are 2 points that we know are on this exponential function. Now, what we're going to do to start is we're going to actually create a system of equations by using these 2 points. So we know that the a and b value that work with these 2 points need to work with both of them. So what we're going to do temporarily is we're going to take this equation form, y equals a times b to the power of x, and plug in what we know for each point. So here we know in the first point that x is 1 and y is 6. What we're going to do is we're going to take this form here, plug in 6 for y and 1 for x. So here we have 6 equals a times b to the power of 1, because that's what we know. Then for the second point, we're going to create a second equation in that same fashion. So y is 54, so we have 54 equals a times b to the power of 3. So we start by creating a system of equations. Then what we're going to do is within this system of equations, we're going to use the substitution strategy. And remember, with the substitution strategy, we always get one variable alone. Now, what I suggest you do is that you pick a in one of these equations. It doesn't matter which a value you pick, but I suggest you pick an a value in one of these equations because a doesn't contain an exponent, so it's a little bit easier to get alone. So what I'm going to do is I'm going to get a alone in this particular equation. So in order to get a alone here, what I need to do is I need to divide both sides by b to the power of 1. So here we know that a is equivalent to 6 divided by b to the power of 1. So what I'm going to do is I'm going to take what a is equal to, and I'm going to replace it in the other equation. So if I go over to this other equation and I replace a with 6 divided by b to the power of 1, I'm going to have 54 equals, a becomes 6 over b to the power of 1 times b to the power of 3. So I've now replaced a in that particular equation. But what's helpful here is while this looks a little complicated, I can now use this equation and I can solve for my b values. Well, I know I need to find a and b. If I start solving for b, I'm at least finding one of them. So here I'm going to rewrite this a little differently. I have 54 equals 6 over b to the power of 1 times, I'm going to write this as b to the third over 1, so it's 2 fractions that I can multiply together. So I'm going to move my work up here. So this then becomes 54 is equal to, that becomes 6 times b cubed over, it's just 1 times b to the power of 1. I know using exponent properties that I can subtract the exponents here to simplify this, so I can take 3 minus 1. So I end up with 54 is equal to 6 times b squared. Now I can solve for b quite a bit easier, so I divide both sides by 6. So I end up with 9 is equal to b squared. To undo a squared, I use a square root. So if I square root 9, I know that b could possibly be a positive 3 or a negative 3, because either one of those numbers when squared gives me 9. And then if I realistically think about this, I know that this multiplier value has to always be positive. So b is always greater than 0, and because of that, I can eliminate the negative 3. So I know that my b value here is equal to 3. So I found at least one of those values, and I now know that y equals a times 3 to the power of x. So I found at least one of those. Now what I need to do is I need to find my corresponding a value. So that's going to be my fourth step here. So I need to find my a value. And the easiest way to do that is to use one of the original equations that I created for my system. So take b and plug it back into either one of these original equations. It really doesn't matter which. I'll show you why we can use both, or you really can use whichever equation you would like. So I'm going to test it out in both, see what I get. So I have 6 is equal to, we have a times 3 to the power of 1. So this becomes 6 equals just 3a. Divide by 3, I find that a is equal to 2. So at this point, you could stop and you could write, okay, my equation is y equals 2 times 3 to the power of x. But just to make sure that you understand that we can use either equation, let's test out this second one as well. So we have 54 equals a times 3 cubed. Well, 3 cubed would give us 27. So if I divide both sides by 27, I again get an a value of 2. So you can see how once we find our b value, it doesn't matter which of these two equations we use. So in the end, we were able to use our system of equations that we created using those 2 points to find that our equation for this particular function is y equals 2 times 3 to the power of x. So let's jump in here and look at a second example. This one says that a store sells baseballs, and the table below shows the number of baseballs y sold during each year x the store has been open. Write a function to model the data. So we have a couple of different points we can choose here, and it doesn't matter which points we choose. Just for the sake of mixing this up, I'm going to choose the point 2, 31. So that's one of my points there. And then I'm going to choose the point 5, 56. It doesn't matter which point you choose, but to write a function, you always need 2 points. So the first thing we need to do is we need to choose 2 points in our data. It doesn't matter which 2, but you need to choose 2. So here we're choosing 2, 31 and 5, 156. So then from here, once we've chosen our 2 points, if we want to write an exponential function for this situation, we need to remember that we're going to be writing it in the form of y equals a times b to the power of x. So we need to essentially create a system of equations by using the 2 points that we picked. So here we have x and y, and we're going to substitute those temporarily into our equation. So here we have 31 is equal to a times b to the power of 2. And then we also have 156 equals a times b to the power of 5. Now from here, once we've found that we have our 2 equations, so we have our system, what we can do now is we can use the substitution strategy to solve this. So by using substitution, we are going to need to get one of those variables alone in one of those equations. I always suggest getting an a value alone because it's easier since b contains an exponent and makes things a little more complicated. And it doesn't matter which a value you pick, so I'm just going to pick this a value in the second equation. So if we do that, we end up with 156 is equal to a times b to the power of 5. We want to get a alone, so we divide by b to the power of 5. So we end up with a is equal to 156 divided by b to the power of 5. So from here, if we now substitute this value for a back into our other equation, we end up with 31 is equal to 156 over b to the power of 5 times b squared. And now if we start simplifying this a little bit, we end up with 31 is equal to 156, or we can put b squared over 1, so it would be 156b squared over b to the power of 5. Well, if we simplify this, remember we can subtract the exponents and then leave, the b values where there are more b's to start. So if we take 5 minus 2, that's 3. So we end up with 31 is equal to 156 over b cubed, because we did 5 minus 2 and then left them where there was a bigger number. Now, I don't know about you, but I don't like looking at a fraction like this. I know that's going to be pretty complicated. So I can get the b cubed out of my denominator by multiplying by b cubed on each side. So now I have 31b cubed is equal to 156. Divide by 31. We have 156 divided by 31. That is approximately 5.03. Now from here I know that in order to undo that cubed, I need to use a cubed root. So I end up with my b value is going to be equal to the cubed root of whatever 5.03 is. Now that's not super easy to do in my calculator, but I know that cubed roots are related to fractional exponents, so I can turn any root into a fractional exponent. So the equivalent statement here for b equals the cubed root of 5.03 is b equals 5.03 to the power of 1/3. Remember, that's how cubed roots and fractional exponents are related. What's out here in the root goes into your denominator, and then you have a 1 up in your numerator. So if I take 5.03 to the power of 1/3, I end up with a b value that is approximately 1.71. So just by using substitution on this system, I was able to find my b value is about 1.71. So b isn't always going to be some nice integer multiplier. It's sometimes going to be something that's a little bit more complicated. So now in this next step, we're going to use our b value to find our a value. And it doesn't matter which original equation we use. We just need to use one of these. So I'm going to use this first one here just because it's the first equation. So here we have 31 is equal to a times my b value of 1.71 squared. Well, 1.71 squared ends up being 2.92. Divide each side by 2.92. And we end up with an a value that is approximately 10.62. So we now have our a value and our b value, so we can finally write our final equation of y is equal to 10.62 times 1.71 to the power of x.